The last topic we need to address with reaction stoichiometry is efficiency. Say you need to make sandwich cookies and you're given 10 wafers and 10 frostings, and we can calculate how many sandwich cookies that we're able to make. By now, you should know that you would need to assess for each reactant individually. 10 wafers would be enough to make 5 sandwich cookies, and 10 frostings would be able to make 10 sandwich cookies. So the maximum number of sandwich cookies you can make with this ingredient is 5. And we're going to call this our theoretical yield. The theoretical yield is the calculated amount of product that you should be able to make. Now, unfortunately, not all reactions produce exactly what they should. Suppose you're making these sandwich cookies and a couple of the wafers break, rendering them useless. This will cause you to only be able to make 3 sandwich cookies. This is going to be called your actual yield, because this is the amount you actually were able to make. So what happens in a chemical reaction to cause a lower yield? Well, sometimes the product created is lost to other reactions, or sometimes the reactants don't all react fully. Either way, when we perform reactions, our goal is to create as high as a yield as possible, as close to the theoretical yield as possible. And one way to compare the actual versus the theoretical yield is by calculating something called a percent yield. The percent yield is the percentage of the theoretical yield that was actually made. It's the ratio of actual over theoretical times 100% to convert it to a percentage. Now, in our scenario, we broke some of the wafers, which made them unable to form cookie sandwiches. We could only make 3 out of the 5 sandwiches that we should have been able to make. This gives us a 60% yield. Now we can tackle a chemistry problem. Pause the video, see how much of it you can do on your own, and then when you're finished, push play and check your work. Okay, here we go. Step 1, balance the equation. We have a 2, a 1, and a 2. And I'm going to keep the 1 there so we can see those ratios. Step 2, notice this is a limiting reactant type question. We're given different amounts of both ingredients, and we don't know if they react in perfect proportions. So we need to figure out the amount of product made with each reactant individually. The next thing we do is we pick a reactant and solve for the mass of water, which is what it's asking us to do. And I'm going to show you a shortcut here. We're going to start with 13 grams of hydrogen. Each mole of hydrogen, H2, has a mass of 2.0 grams. And for every 2 moles of hydrogen used up, 2 moles of water are produced. And we're going to stop there just for a minute and see that this gives me 6.5 moles of water. Now you could keep going onto the mass, but I'm going to stop here for the time being and move on to the oxygen calculations. We're going to start with 41 grams of oxygen. 1 mole of oxygen has a mass of 32 grams, and 1 mole of oxygen will create 2 moles of water, and that will give me 2.6 moles of water. Now, before continuing to the end, I can identify my limiting reactant. It's the one that produces the least amount of water, whether it be moles or grams. So oxygen is the limiting reactant with this quantity of ingredients, this ratio of ingredients. So I'm going to finish the calculation just with the oxygen, and that allows me to reduce my number of calculations by 1 step. So 1 mole of water has a mass of 18 grams, which means that 2.6 moles of water has a mass of 46 grams. That is our theoretical yield. Now, according to this question here, the actual yield is 34 grams of water. So to calculate the percent, we would take 34 divided by 46, multiply that by 100, and I get 74% for this. So 74% is our percent yield. Now remember, it's actual over theoretical, or sometimes people choose to use the term experimental over theoretical. Experimental meaning what you get in a laboratory situation, and theoretical meaning what you get when you type it into a calculator. Keep in mind, the actual will always be smaller than the theoretical, and a perfectly efficient reaction would have a 100% yield.